Hey everyone. Alright, in this section we're going to look at inverse function. Now you should remember from secondary math 1 that a relation is a pairing of inputs and outputs. Basically you have a list of x's and y's. Okay? Now an inverse, what that does is it interchanges those things. So all of your x's now become y's and all of your y's now becomes x. Okay? What that essentially is doing is it's reflecting. And it's reflecting across the line y equals x. Okay? So a basic example is this. I've got these inputs and outputs, these x's and y's. If I look at the inverse, and you see right here this f of -1, that's the symbol for inverse. What happens is my x's and my y's switch. So all of my y's now become my x's. So I've got a -3, -5, 4, -9, and 2. All of my x's now become my y's. So I have 3, 5, 9, 12, and 15. Alright, so all of my x's, all of my y's switch. That's one way to tell that something is an inverse. Now we can also take an equation and create an inverse using a two-step process. Okay, the steps are interchange your x and your y, and then solve for the new y. So if the function I'm given is y equals 3x minus 5, I'm going to rewrite that by switching my x and y. So x equals 3y minus 5. Then I'm going to go through and I'm going to solve back for y. So it's going to cause me to add 5 to both sides. So I have now x plus 5 equals 3y. And then I'm going to divide by 3. And that gives me y equals x plus 5 over 3. That is my inverse function. Okay, and if I substituted in an xy for the first problem, and I reverse those and substitute it in for the second problem, those numbers should work. Okay, now for this second one, same idea. Now the difference here is I have a squared term. Okay, so let's see what happens. So I've got an x equals 4y squared. Now I've got to solve for this y. So first step might be something like divide by 4. Now the reason I do that first is because I want to get that y squared by itself. So I have x over 4 equals y squared. Now think to yourself, how do you get rid of a square? Well, you do the inverse, which is square root. So I'm going to square root those. So that square and the square root cancel. I'm left with y. My y is now by itself. Now here I can simplify a little bit. The square root of x is just going to stay the square root of x. But the square root of 4 is just 2. And so my inverse is y equals square root of x over 2. A lot of times, like I showed, you'll see that -1 there. And that is the inverse. So that's how you're going to solve these things using a two-step process. The final possibility is something where you're given a graph. Now I have these points and they would make some function. Okay? Now what I want to do is I want to find the inverse. Well, the inverse is the reflection across the line y equals x, which is this line that I have here. Okay? So normally that line won't be on the graph, but for this purposes it's going to be. So what ends up happening is I take all of these points and they get reflected across that line. Now you can sketch that roughly, or you can do it rather accurately. So here's one way to look at it. This first point is the point 5, 1. Well, if you think about what we talked about a few minutes ago, this just takes the points and switches them. So 5, 1 becomes 1, 5, which is that point right there. Okay, the next point is 4, 1, which would become 1, 4, which is placed right there. Okay, the next one, if you look at it, you've got 3 and what looks like about a half. So it's 3, 1/2. So I'm going to go 1/2, 3, which is about right there. And hopefully you can start seeing that these are truly reflections. The next one looks like 2.5, 0. So I'm going to go 0, 2.5. The next one looks like 2, -1/2. So I'm going to go -1/2, 2. Okay, the one after that looks like 1.5, -1. So I'm going to go -1, 1.5, which is right there. Final two would be 1, -2, so -2, 1, and 1, -3, which is -3, 1. And you can see from my green line, they look like they are indeed reflections. And not a bad idea, but I could sketch these lines, and taking a closer look, they look like they are reflections across that line, and that's that. So that's how you can create inverses. All right, if you have questions, definitely let me know.